What's up, everyone? Hello, 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 hello. Looks like we're live. Awesome. Very, very cool. Hello, 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 hello. Hope everybody's doing well. We will get started here in just a couple of minutes. I wanted to make sure everybody can hear me, that all of the pieces that need to be in place are working. So, for example, the video is obviously working because you guys can see me. Is the audio coming through? I can see it on my streaming software. It's going up and down to make sure everybody can hear me. What's up, guys? Tom, Radu. Hello, hello, hello. Good stuff. Hopefully everybody can hear me all right. I'm going to assume that that is true. I can see the little wave of green, yellow, red going up, so I think we're good there with the live. Awesome. Thanks for that. Awesome sauce. Cool. All right. Well, so in this stream, for any of you guys that are looking at what we're going to be covering, I'm going to cover that real quickly, what we're going to be diving into, and stuff like that, because the topic of discussion for today is going to be diving into some VPNs. It's a technology that I struggled with a lot when I first got really get started in the industry, and something that I struggled with a lot. It was understanding how everything worked in phase 1, phase 2, and what's the difference between the two, and how do you configure them, and things like that. So that's something that I know if anybody is working on making the jump from CCNA to CCNP, whether it's especially for in the enterprise track, if you're still relatively new to the networking field, maybe you have a CCNA, you're working on the enterprise track, and you're working on your CCNP, and I struggled a lot, actually. So I see Paul's on the stream. What's up, man? So when I was going through and learning these technologies, it was definitely had to put a lot of time and effort into those areas. So a lot of the stuff that I see people going from CCNA to CCNP, that's a huge, it's not so big on the Encore, but it's heavier on the NRC exam because of the fact that they cover DMVPN. And especially if you look at the CCA Enterprise Infrastructure Lab exam, the practical piece of it, they do talk about doing dual hub DMVPN, and there's a mention of IPsec in there. So in the version 5 lab of Route Switch, there was IPsec. So naturally it's something I had to cover, and I became more and more comfortable with it. So we're definitely going to be diving into how all that stuff works as we get further into this. And if you guys have questions at any point in time on whatever it might be dealing with when it comes to IPsec VPNs, I'm going to ask that you keep you have a question that you focus on that, because it'll be difficult for you to ask me the deep dive question on, say, I don't know, VXLAN or BGP or something like that would be completely off topic. So keep the questions tied to that. That'll make it easier for me to correlate the question to what we're talking about and stuff like that. I'm going to be doing some whiteboarding, and we're going to go through several examples of how all this stuff works. So we're going to do it. My goal here, let me go ahead and share my screen, actually, since I'm at this point. I'm going to go ahead and get out of the way. What you're going to see is we're going to be talking about IPsec at a high level, how it all works and that type of stuff. And then we're going to be going through and getting the IPsec VPN set up. We're going to start off with the crypto map. And when we get the crypto map variation up and running, which will be, in my opinion, is the more complicated version out of the gate, because there's a lot of things that need to be matching and working and correct in order for the VPN to come online. And then after a little bit, we'll go ahead and bring myself back in. Once we cover how the crypto map variation comes into play, then we'll take a look at how the tunneled variation comes into play, which removes some of the complexity that a crypto map variation adds to an environment. So for those of you that are running IPsec VPNs in your environment on like a Cisco router or an ASA firewall, or really any other platform for that matter, they're pretty straightforward for the most part. I mean, crypto map VPNs have been around for a really long time. There's some significant drawbacks to them as well. So we'll talk about how those come into play. And then my goal is to add in some complexity. So one of the common things that I've had to deal with when it comes to IPsec VPNs is number one, I need the VPN to be up and running. So I need to set up communication between two locations over internet as a transport and encrypt it. So that's the whole purpose of this solution, is that particular capability. And then adding NAT. How do you bypass the NAT process and go right to crypto? So we'll take a look at how that comes into play and where that would be a scenario that you could definitely run into. We'll talk about how the router looks at that, because there is an ordered step of processes that the router is going to go through in order to determine, okay, does this or does this not get encrypted? And we'll talk about how the router processes that and how it determines what to do and when to do it and things like that. So I'm going to go into how that works. And then once we cover those things, then we're going to actually remove the crypto map itself, and we're going to transition over to the IPsec profile. The IPsec profile will give us more flexibility long term. So we'll be able to move from a policy-based cryptography or IPsec deployment, where we use a crypto map to call an access list to determine what gets encrypted, and we'll flip over to the methodology of using a tunnel, where we'll remove the policy piece of it with the crypto map, and the routing decision will then be determined based off of what is my outgoing interface and what is my next hop. We still have to make that determination with the crypto map, but it's easier when you're saying, okay, I'm going to recurse to a tunnel, whether it's a static VTI, a DVTI, or a GRE tunnel. It doesn't really make much of a difference. But when you go through the config and you set it up, it's easier to explain a tunnel-based and easier to deploy tunnel-based VPNs than it is especially with a crypto map. Or when you remove the crypto map, it's easier to roll it out. And the reason why, for the most part, is you're removing that extra step of, okay, now I have to deal with the cryptography piece and my natting. If you're natting, that NAT alone with the VPN at the same time and having to determine what traffic gets encrypted versus which traffic gets natted, that can be complicated. So I'm going to do my best to try to take those pieces and chop it up so that it's easy to follow and that type of stuff. But once you get through those pieces, then the rest of it's pretty straightforward. Once you have the tunnel up and running and you get all that stuff squared away, then you're recursing to a tunnel, then you're hopping over whatever transport you're using as the underlay, and you'll be good to go there. And then we'll focus on doing things like GRE over IPsec, and then we'll take a look at DMVPN, which is the next iteration, if you will, of IPsec. So it's going to be the DMVPN has been around for a really long time. It's not something that's new necessarily. It is a topic that you're going to have to go through and learn pretty well. And what's actually kind of funny about this is I've worked with a lot of customers that don't realize that DMVPN does not mean out of the gate encryption. They automatically think VPN, it's going to be encrypted, which isn't true at all. You can have a VPN and not be doing encryption at all. So for example, like MPLS Layer 3 VPN, it's a virtual private network, but it's not encrypted. But we'll talk about how that comes into play. I've got a simulated WAN here with MPLS. I've got a simulated internet circuit here for internet. We're talking about how to get that stuff squared away, do some basic routing, and talk about how all that stuff comes into play. So this is going to take us a while to unpack and walk through. So If you guys have any questions as we're going along, feel free to ask. I will do my best to try to answer them and stuff like that. We're not going to be deploying firepower in this video or in this session. This video, it's live. It will become a really long video once it's all said and done. But I won't be deploying firepower in this lab. Simply for the fact that I don't have it booted up yet. It's resource intensive and stuff like that. So we'll definitely take a look at how the pieces that I said we're going to take a look at roll out. And if anybody got questions and stuff like that, let me know. This topology will be available after I get done with the live stream. I will go ahead and, if you are a current member of the channel and you've clicked the join button and all that good stuff, then for the low price of $10 a month, you can become a member. And the cool thing about that is any of the topology files that I create that go on the channel, and you're a member, you automatically get the topology file. And I'm working on the initial configs. So I know I keep promising that, but I swear I am going to put that out there. But the initial configs as well, and you'll be able to download the topology file, import it into your Eve environment, and then be off to the races. So you'll get that and all the good stuff that goes along with being a member. So I'm working this year. I'm planning on doing a lot more with that type of stuff. And instead of trying to do like large blocks of training where I knock out 30, 50, 70 videos on something and then upload them one day at a time, I'm going to be breaking them up into much smaller chunks so I get more content out on a more regular basis, because recording does take a while. I'm sure you guys can understand that, but at the same point in time, it's a matter of going through and not trying to do a bunch of content where I'm really quiet. It's do a little bit here, upload, do a little bit here, upload. So anyway, with that being said, let's go ahead and take a look at our breaking down the VPN piece itself. So I'm going to be walking you guys through a bunch of the theory and how it works and how the router makes its determination. I'll get the ASA up and running with the VPN. We'll do a site-to-site VPN on the ASA through the CLI, and then we'll go ahead and set up some peerings and correlate how the outputs work and do all that type of stuff, so that hopefully by the time this stream is done, we'll have covered a lot of things and you guys will be pretty well versed in how everything comes together. This is something that I spent a lot of time learning, and I've got the CCNP Security VPN exam scheduled. I will be taking that very soon. So this is actually just good practice for me to go out and play around with it some more. So it gives me some lab time and things like that. Hopefully you guys will benefit from it as well. So let me go ahead and create a custom shape real quick, and then I will make that pretty big so we can scoot it down and we have a whiteboard to work with. So I will go ahead and I'll be able to scoot up and down in the page. So I've got about a 10-second lag or so from when I do something to when it actually shows up in the stream. Let me go ahead and pull up my pen tool real quick, and then we'll go ahead and get started with the initial piece of it. So alright, so I do have the chat up, so if you guys have any questions, throw the questions into the chat and I will do my best to answer them. Go ahead and start with white as our color. Alright, so there's a couple things that we need to understand when it comes to how the VPN comes into play. So out of the gate, we're going to have phase 1 and we're going to have phase 2. So what this simply means is this is going to be the ISAKMP piece, ISAKMP, or the IKE, the Internet Key Exchange. And then down here we have IPsec, or IP security. Now this is going to be, I like to correlate this automatically to the control plane, and I like to correlate this immediately to the data plane, because that's really what they are. So really, what's the difference between the two, and what is going to be, what makes them unique to themselves, and how are they different, and that type of stuff. Well, what's interesting about it is, and this is something that when I first started diving into IPsec, I was just like, okay, I see a lot of overlap, so it made it difficult to really understand what was really being discussed. So this guy right here is going to be you're gonna have a policy, and so the policy itself, you're gonna have a number that's associated to it. So let's say, for example, we use the policy number of 10. This number right here is also referenced as a priority level. So the lower the number, the better. So if I have 10 and I have 20, then this one is checked first. This one is checked first, and this one is checked second. So can you have multiple policies? You sure can. So there's a question: is it beneficial to have such a large topology? I see this a lot for labs. It just seems to make things too complex for not much a reason. I feel like the bigger the topology, the more variations you can run, and you can make it more real world. So if you only have, say, one router and one firewall, guess what? You only have so many options to play with. When you add more devices into your topology in your lab, it gives you more variations to play with. You can scale it out, you can make it more real world, and to me, I'm all about real world. If you're not pushing that envelope of, like, once you understand something at a base level, like a standard site-to-site VPN with a crypto map, if you do that between two routers, and that's as far as you take it, and you're comfortable with that, because that's all you need to learn for your environment, then that's fine. But if you're like me and you work in a lot of different environments, not just one, I work in the consulting world, so I spend a lot of time in a lot of different environments. So limiting myself just to that one variation doesn't really give me any scalability or advanced understanding of, say, DMVPN or FlexVPN or GetVPN or something along those lines. So the more complicated you can, or the more you enhance your lab to be bigger and add more complexity, and you bring your learning level to that level of that complexity and you understand it fully, and then you add more complexity by making it bigger, and then you had to understand all those pieces. If you do a notched approach, add more and more complexity as you're going, then the better off you're going to be. If you're just starting out, like you literally don't know anything about IPsec, a router to router connection, and then you have a couple of LAN segments that are like, say, loopbacks, and you do something simple like this is more than sufficient to start with, right? So then you can run IPsec over the top of this, and that will work 100%. But if you are trying to learn IPsec in all of its different variations, because believe me, there's a lot you can unpack with IPsec, then you're going to need a larger topology. But you can start with one and work your way into the next. Do you utilize OneNote or some type of digital notes to store notes? Yeah, I have 100%. I use OneNote all the time, and it's cool because then you can scale them a little bit, add some hierarchy to it, and I just go ahead and if I'm like studying DMVPN, I'll cover that in like the DMVPN overview. Then I'll talk about phase 1, then phase 2, then phase 3, then VRF aware DMVPN and how that works, and dual hub, dual cloud, dual hub, single cloud. There's a bunch of different variations for it. So 100%. If you don't have some sort of note-taking capability, you should start. Cool. Yeah, I'm glad that worked out for you. So, like I was mentioning with the policy, the lower the number, the more preference or the higher priority it's going to have. So if you have two policies, 10 and 20, you might be using this for, say, customer A or whoever you're peering to, and you might use this for customer B. So this one will always get checked first, right? Because it's got a lower number. Because you might need two different ISAKMP policies based off of who you're peering to. Because let's say, for instance, that customer has one defined policy that they're going to use for all their locations, and let's say you work in the consulting world and that's a dedicated customer. It's almost easier, or let's say it's a data center that you're helping to manage. It's easier to set up a site-to-site VPN between your location and their location and spin it up that way and then meet their requirements versus having them meet yours. Because if you're a consulting engineer, you should be comfortable with adjusting whatever config to meet whoever you're working with, at least if you have the capability of doing so. So I will always be like, okay, well, send me your config, and then I will go ahead and build mine to match yours, and then I'll set this. We'll get the VPN up and running and go from there. So I tend to, if I'm consulting or I'm a consulting engineer working with a client, I would rather set up a site-to-site VPN with their location so that I can just pull it up on my computer, and instead of having to like any connect in and jump and then once I have any connect in and then have to manage it, there's some things are better with the site-to-site than remote access. So with that being said, if you have a scenario like this where you've got two different customers, you can keep one policy for them, one policy for you, and if policy 10 will be checked first, and then if it doesn't match, it'll move on to policy 20, and policy 20 matches. What's going to end up happening is whatever consists in this policy and in this policy has to match whoever you're peering to. So if you have us, and then we have policy 10 has a certain number of attributes, right? And then you have customer A, right? They are going to have, let's say, policy 100. This information right here, that's exchanged back and forth, it must match. You cannot not have that happen. It has to be the same on both sides for the ISAKMP policy. Whether you decide to use a pre-shared key or you're using a certificate doing PKI authentication, it doesn't make a difference. You have to make sure that whatever you're doing on your side is matching what they're doing on their side, because the attributes have to line up. If they don't, that's a problem. Now, for example, if you do policy 20 and you have those attributes and you have customer B that's using policy 10, for example, and it's got its attributes, again, those have to match. Okay, so once you go through that process, can you add more and more and more? Yeah, I can add policy sequence number 30. I can do 40, etc., 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 and scale it as much as I want to. Just remember that 10 will be checked first, 20, 30, 40, etc. Sometimes the customer has multiple sets as well, and you don't match the one you want. Well, in that case, if you don't have a match, then it's never going to fail, or it's never going to come up. So, and that's also, as long as you have a match, it's fine. But in the point that he's making is that you want this guy right here to land on this one is what he's referring to. But it might be that you want him to land on policy 20, but customer B actually lands on policy 10. So that does happen. And you also have the option of using, he said, RSIG versus PSK. RSIG is what they refer to as RSA signature, meaning a certificate. So, yeah, it can, as long as it lands on one that matches, it's fine. It's not like you're gonna have like a huge problem. Then, but it depends on the scenario at hand. If you want to be super specific, you can be, but just remember that the moment a match is found between your current ISAKMP policy and their current ISAKMP policy, as long as there's a match, it may not fall on the sequence that you want it to, but as long as it matches, you're in good shape. That's really what it comes down to. All right, cool. I might have to clear the screen, but what ends up happening, the policy number is kind of irrelevant. Whatever number you choose to use, there's a bunch of ones that are already there in the routers. You can do, there's like an ISAKMP default command. You can look at what's already there, and they start at like 65,000, like 531 or something like that, some really high number, which means it's low, really, really, really low preference, right? So if you don't configure anything, there's technically already one there for you, and I'll see if I can't pull it up. It's not on every version of iOS. I've seen it hit or miss, so just be aware of those things that come into play. But they are out there, and sometimes can be detrimental if you don't. Detrimental is the wrong term, but I typically like to define everything that I'm doing so that I know what I'm matching on. So I'm not trying to. There's no guesswork involved. So there's that piece as well. Then you're going to have some pieces of information in here, like you're going to have your authentication mechanism. You're going to have your auth method. I'll put authn in here. which will be one of a couple different things. You'll have either a pre-shared key or you'll have a certificate. Now, the cert is what Keanu was referring to as the RSA-SIG. There's another one in there. I can't remember off the top of my head what it is. I'd have to go look at the config. But we're not going to be looking at certificate-based authentication in this session. That will be coming at probably in a later live session. But you can 100% go out and have a certificate set up for your local box and then use certificates to authenticate other VPN endpoints for site-to-site VPN. It 100% works. I have tested it. I've deployed it. It's not difficult to do. It's just more complicated than a pre-shared key. So it depends on what's going on in the real world. It depends on who you're peering to. I'd say 90+% of the customers that I've worked with have always run with a pre-shared key because it's oftentimes it's easier to run a pre-shared key and have a PSK per peer than it is to go out and have a different certificate per peer. But it actually comes out to be a wash when you do that, because if you're dealing with a certificate and you're the one that's issuing the certificate, like let's say you got your own Microsoft CA internally, you can actually generate a identity certificate per peering, and then what you can go through and what you can do is you can go into the CA and you can actually revoke whichever certificate. We'll say that device got compromised or whatever the case might be. You can go through and revoke that certificate for that particular VPN peer if you want to do so. Or you can, same thing with a pre-shared key, you can just know it out and remove it. So I typically don't like to use the same pre-shared key per peer. I like to use multiple. So it depends on how big the deployment is as well. If you've got thousands of endpoints, that's thousands of pre-shared keys. It makes it more secure if you do that, because then it's a one-to-one match, but not always going to work for the customer. So yeah, we're talking IKE1 right now. Yeah, we're not setting anything underneath. We're not talking IKE2 at all. We're going to talk about IKE2 in a later session. And yeah, you can do it either underneath the profile or you can do it underneath the keyring. You can do it under both. Either one, it's up to you. And then you can call the keyring from the profile. But we'll talk about IKE2 in a later session. And then you have your encryption. So I'll put in here, we're going to use like AES, something relatively strong. And then you have your hash. Your hash is going to be like MD5 or SHA. And this is basically taking the information that you're passing back and forth, and you are putting a level of integrity to it. So when you're passing the data between your VPN endpoints, the information is checked or hashed. So it's passed through an MD5 hash. It's given a signature or I'm sorry, not a signature necessarily, but you could call it a signature. I like to call it a fingerprint. It's a unique ID that's given to that particular piece of data. And let's say, for example, the data is 10AC Delta Echo 101. Let's say that's what comes out. Oh, actually, because it's going to be a hash, let's put a dot, a backslash, and a $sign. So that's going to be what's given, right? So for those of you that you're like, well, how does that work? For any of you that have ever used the enable password command, where you've done enable secret and say Cisco as your enable password, and instead of it showing up as Cisco, it shows up as some gobbledygook output that you can't understand. That's the hash. So if you're using MD5 or SHA is going to have a larger bit processing, so it's going to give you a larger key size, and then you will be able to pass whatever password you're going to push through. It's a one-way hash. So you take your clear text password and your clear text data, and you push it through the MD5 hash or the SHA hash, and it's going to kick out some sort of information that is going to be used to check. It's going to be a sanity check on the other side. So you'll pass that information back and forth, and this will determine whether or not data has been modified. So the moment you modify anything, this value right here will change. So maybe this becomes an E, this becomes a 0, this becomes a $, for example. So things will change, and what ends up happening is your fingerprinting or your signature is different, which means there's something wrong with it. Something's been changed. So You can do this for the data encryption as well. We'll talk about that later on. Then we have the group. We have our Diffie-Hellman group. Diffie-Hellman group is going to be used to protect the data, similar to the way that encryption works. If you want to dive more into that, you can feel free to do so. Once we all have these pieces in play, we're going to configure our ISAKMP policies for them all to be present, because there's some defaults that are there. We're going to configure our policy to be different than the defaults, so that all of the authentication, the encryption, the hash, and the Diffie-Hellman group will all show up in the show run. And then we'll have to take the policy that we've configured and whatever values or attributes we've applied to it, we'll have to get applied to the other device that we want to peer to. So we'll get that going. Now, there's one other piece to this. We're going to be using a pre-shared key. The pre-shared key is part of the phase 1 process. So I'm going to bring this piece down here, talk about it. You have the pre-shared key. Now, there's a number of ways that you can configure this. You can create a pre-shared key, and which would be the crypto key, and then you give it some similar flow, or crypto ISAKMP key, excuse me. So similar flow to like setting up SSH on your router, but overall a little bit different as well. What you end up doing is you can add in who it is that you're going to peer to. So you're going to have an address option for that. And the reason I'm stopping here is because the address can be done a couple different ways. You can configure the address to be host specific, or whoever you're trying to peer to specific. So you can give it 1.1.1.1/32. So you're specifically only going to set up a peering to that particular IP address. Now, if you have a static IP at that location for your internet connectivity, great. Then you know it'll never change. But if you don't, and you have, say, DHCP, like here at my house, I have a DHCP assigned IP, public IP. So that means that if I don't know the IP address, I need to go find out what it is, and then whoever I'm going to peer to, that IP address needs to be in their configuration. Now, that's one way of doing it. I've worked in some rather large environments where there's several hundred VPN peers that you're connecting to, or spokes, depending on how you want to correlate it, depending on the size of the environment or how the environment is being built. But I've been in environments where several hundred IPsec peers is who I'm peering to. So sometimes you'll see companies use a all zeros option as well, which is basically saying I don't care who is going to be connecting to me, as long as their password is correct, I'm fine. This will become a little bit more, it's good for the lab, right? This is good for labbing, but I wouldn't recommend it in a real world scenario. I very rarely ever see all zeros out there. I will see a number of public IP addresses defined, and then I'll see a number of pre-shared keys defined. Excuse me. I have seen crypto configs that are several thousand lines of code, and the bulk of it is the pre-shared key piece and the ACLs for the crypto map, and then the crypto map entries. Because for every person you're peering to, you're going to have a different sequence number in the crypto map, and we're going to talk about that in a little bit. I'm actually going to do multiple peerings from one device to a bunch of other devices, so you guys can see what that looks like. But you're going to see that, and that's what makes the config pretty lengthy. That's one of the drawbacks to a crypto map based VPN solution, or in this case here we're tying it back to a policy, so you have to match on a number of different things in order for this all to come to work out. If you get rid of the crypto map, you actually reduce the complexity of the config and make it easier to deploy. You get rid of the ACL for the matching of what gets encrypted and things like that, so it makes it easier to roll out, it makes it easier to scale. So things like DMVPN and FlexVPN, I see more customers using this IPsec profile than they do a crypto map. Plus, if you can tie crypto maps to your DMVPN solution. I've never tried it with the FlexVPN. I'll give it a shot to see how it plays out. But those solutions were never built to work with a crypto map, because there's better ways of doing the encryption than using a crypto map. One of the main reasons why a lot of customers don't like using a crypto map, they would rather use the IPsec profile, is for the simplicity of adding capability. Number one, with a crypto map, there is no additional IP address. So this is also going to be for the IPsec mode of transport. So you're literally just taking whatever data is going to be pushed through over the IPsec VPN, and you're literally just encrypting it with ESP. That's basically all you're doing. Where if you're going to be using a tunnel, you're going to be normally adding a second IP header, which is what they refer to as tunneled mode crypto, where you're going to be adding an extra IP header, especially if you're using GRE, it's going to be additional IP header and an additional GRE header. So it's going to be more control plane encapsulation, which means less data plane encapsulation. So some stuff we'll talk about later on. So you're going to be thinking of it, for those of you that know what a semi-truck is, and you see a tractor trailer. So you see the tractor, you see the trailer. Some tractors are much smaller than others, right? So you have what is also known as a day cab, where the driver sits where they are, and there's nothing physically behind the driver other than you have the cab ends where the driver sits. Where you have other options where you have over-the-road trucks, where you have a much larger cab where the driver can get out of the driver's seat and go sleep in the back, right? So in a situation like that, the bigger the tractor means the less weight that can be put in the trailer. So that means that my size is going to be the payload, the actual data that I'm trying to get encrypted. I won't be able to send as much of it per segment size. So a couple questions coming in. Are you aware that Cisco launched multi-SA proxy on VTI in 2019? Multi-Security Association proxy on VTI. I'm not aware of what that is, so you'd have to give me some reference, which in this feature you can attach an ACL to the IPsec VTI. I don't know why you would do that. To me, that doesn't make any sense at all, because the whole purpose of moving to VTI is to add a tunnel, so you're no longer having to do any type of ACL or crypto map like operation, and then you're you're adding dynamic routing. So with an IPsec VTI, I can configure some sort of dynamic routing, OSPF, EIGRP, BGP, to the VTI connection, set up the dynamic peering between the two, and then use dynamic routing to do what the crypto map is trying to do with the ACL. Yeah, so to me that's kind of dumb, if you ask me. That whoever came up with that idea, that's kind of a stupid idea in my opinion, because now you're trying to do what a crypto map, your VTI is trying to act like a crypto map, and that to me is dumb. I would never ever do that, because I would rather figure out the routing from the internal. So where if that's your justification, fine. I would argue the validity of that deployment, and for the feature always on SA. I mean, why would you need VPNs are always going to be on if you're doing dynamic routing. So unless you have a reason, I'm a routing guy, so I would rather use the dynamic routing protocol in BFD to tie that to. I would argue till I'm blue in the face. Yeah, exactly. So it's a routed policy with VTI. So I get where you're going with it, but I don't like it. To me, you're trying to put a lipstick and mascara on a pig, and you're still going to be a pig at the end of the day. I would rather migrate away from that design and use VTI dynamic routing, and then let the routing protocol figure out what the next hop is. So, but you can put in things like dead period detection for doing that and making sure that the tunnel's always up, and put a keep alive in place. The VPN will stay up. So I guess it really you would have to have a really specific reason for me to want you to go that direction. But I would argue, because the fact that I think that's just, the moment you add in crypto map feature capabilities to a VTI solution, number one, I've never tested it, so I don't know how that would all work. So yeah, exactly. It's so yeah, I guess I'm not a big fan of that solution based off the way you're describing it. To me, it doesn't make any sense to me. But anyway, I'll have to look into that. So, well, I can, for legacy customers. Well, I have so to your point, it still doesn't make any sense to me. I can, well, what, if I'm gonna, that doesn't support, it wouldn't make a difference. Because if the device that I'm connecting to doesn't support VTI, or even even basic VTI, then I'm just going to use a crypto map. And I'll just use ACLs to match on the traffic. Well, I mean, that might be true, but if that's the case, I'm going to push the customer to upgrade at that point. I'm not going to sit there and deal with any of the garbage that comes along with that. So I just don't agree with that line of thinking. It doesn't make any sense to me. If I'm going to do policy, I'm going to do policy. If I'm going to have the ability to do routing, I'm going to do routing, and let the VTI tunnel come online and stuff like that. I've fought enough fires that I just don't agree with that line of thinking. So I'd rather rely on other things that are more stable than that. Crypto maps are good if you're just getting started and you're on a really old code where that's all it's supported. Then as soon as I can get away from it, I'm gone. I do tunnel based as soon as I can. So at any rate, so that's how the pardon me. I also don't want to I want to make sure that you understand that I'm not picking on you specifically. It's the topic that I don't like. So, or the way that it's being implemented, or the reason behind it, that doesn't make any sense to me. So, you and I are good. It's just that doesn't make any sense to me. Yeah, if I'm gonna do something a certain way, like another example of something that doesn't make any sense at all to me is the multi-area OSPF on an interface. That's never made any sense to me. I've read books, I've watched videos. It doesn't make sense. Putting one interface into two different areas at the same time. So yeah, it's certain things just don't make any sense to me. And why networking does some of the things that it does, I don't know. I just don't understand it. But anyway, beyond that, so good discussion. I like it when the chat gets a little interesting. So, but everybody now knows that I'm not going to try to put lipstick and mascara on a pig and call it a princess. So, poor pig. I like that. That's funny. Okay, cool. So now that everybody understands how I feel about that solution, the next piece we're going to talk about, I'm going to go ahead and clear the screen and talk more about the IPsec piece. Yeah, I'm gonna leave that one alone there, Paul. So I'm gonna clear the screen off, and we're gonna talk about phase 2. Phase 2 obviously won't work unless phase 1 is operational. I'm pretty sure that most of you would, if you don't already know that, there you go. So there's a couple different ways that you can deploy this. There's the crypto map variation, which is the first variation we're gonna play with, which requires a couple of pieces of information. Out of the gate, you're going to need an ACL to match on the traffic that's going to be encrypted. You're going to need a peer to point towards. And then number 3, you're going to need a transform set to call in order to encrypt the traffic. Then the crypto map is applied to the interface. And then when the crypto map is applied to the interface, then you turn ISAKMP on the device, and you're good to go. There's another way. The IPsec profile, and what ends up happening here is you simply call the transform set. The transform set is called, and then the profile is applied to the interface, very similar to how the crypto map is, except for when you're doing this, you're not tying, so this would be tied to gig 0/0, for example. This is actually tied to the tunnel. Now, how is crypto map and IPsec profile different? What's the major differentiator between the two? Well, the number one is with the crypto map is tied to the interface, which means when it comes to specifically to the crypto map itself, the crypto map doesn't have an IP address, right? So when traffic is encrypted, let's say you have your data your data traffic. We have the data that's inside of here. What's inside in front of this, you're going to have some headers, right? You're going to have your layer 3, or let's say your layer 4 header, you're going to have your layer 3 header, source and destination, source and destination. With this guy, you're just slapping on an ESP header, right? So you're slapping an ESP header on. Technically speaking, this is in the wrong spot. Okay, so this ESP header is actually put right here. ESP header is placed in front of the data, so the data itself is encrypted. The outer IP, the IP address, this guy right here, this is not encrypted. And you might say, well, why is it not encrypted? Well, it should be pretty obvious, but I'm going to assume that nobody understands why. The reason why it's not encrypted is because the internet routing table, the BGP routers or whoever it is you're passing through, needs to know how to forward your traffic. The to and from is got to be still visible to the internet routing table so that it knows where to forward your traffic. So from my house to wherever it is I'm connecting to, that communication needs to be available and understood in order for the routers to make a routing decision based off of where I'm going. So that needs to come into play. Now, when I talk about the IPsec profile, actually, let me pause there for a second. Now, when it comes to this, I need to do a routing table lookup. I need to figure out where I'm going to send the traffic as well. So let's talk about how the router makes its determination on that. So there's a multi-step process on how this works. So the first step is going to be you have the packet comes into the interface, right? The layer 2 header is removed. Layer 2 header is removed. Number 2, with decapsulation comes deeper understanding. Now you understand where the destination layer 3 IP address is. So you need the destination layer 3 IP. So what this is going to expose is where am I going, right? Number 3 is a routing table lookup. So you take the information that you decapsulated, so you remove the layer 2 header, you expose the layer 3 header, you pull the layer 3 destination IP address out. So now you have where you're going. You look in the routing table. Hey, do I have a route in the routing table? If no, so I'm going to put in here question equal and then a bang, which is no match, drop. And this is going to be a message back to the sender. Hey, no destination host unreachable, or sorry, destination host unreachable, for example. If you have an equal sign and an equal sign, this is a match or a forward. I look in the routing table. I do know how to forward the traffic. Say, for example, a default route or something along those lines, or some more specific match. So /1 through /32 would be a longer match. What I then do is, now that I have a match, okay, what is my outgoing interface, my egress interface, and what is my next hop? So you might have a static route, you might have a dynamic route. It doesn't really make much of a difference. As long as you have a route in the routing table that it comes back with a match, then you're in good shape. The number 4 is you got to take the packet from the ingress interface and you got to move it to the egress interface. So this is where the switching process comes into play. So you switch it. So this could be, oftentimes is going to be Cisco Express Forwarding or Ceph switched. So yes, routers do switch packets from one interface to the other, just like a switch will move a frame from one port to another. That process does happen. I'm going to go ahead and get out of the way and finish this flow. The next thing that's going to end up happening is you've moved the packet from the ingress to the egress. Number 5 is you have to build the new layer 2 header, which is going to have a new source to destination MAC. And then here's the kind of like the icing to the cake for this whole entire process. Number 6 is the crypto. You slap an ESP header in front of the data. So all this right back here, it's all encrypted. And then the traffic goes out to the internet as it needs to. And it gets to where it's got to go. And that's really the breakdown that everybody needs to understand here. Once you get to the interface, the first thing that you need to remember and first thing you need to understand is that when you're dealing with whether it's NAT or it's crypto, you need to make a routing decision first, then move the packet to the outgoing interface. That doesn't mean typically always mean the internet, just an egress interface. So how am I going to leave the router and go to my next hop? The egress, outgoing, they mean the same thing, but it doesn't always mean internet facing. You could be pointing out towards the WAN or anything internal. I've seen people do IPsec VPN internally. It's weird, I know, it does happen, but it's there. It's egress interface. You have to make a routing decision to get you to the egress interface. Once you've made it to the egress interface, then you can either NAT the traffic, so translate it from one IP to the next, or in this case here we're talking about encryption with a crypto map, then you can actually encrypt the data. And then if you're using a crypto map, which we are right here in this scenario, the crypto map is going to look at a couple different things: ACL, the peer, and the transform set. First, which orders does it actually check? I'm not 100% sure on, but what I do know is that as long as these three things match, the ACL, the peer, and the transform set, guess what? I can say, okay, does the traffic that's I see coming in match the ACL? If it does, great. Now I know which IP address I need to forward the traffic towards, and I know how to encrypt it with the transform set. Now, if the traffic doesn't match the ACL, what happens? Nothing. It keeps on right on going. There is traffic that will pass by the crypto ACL that does not get encrypted. Now, I haven't talked about NAT yet because I'm not going to add too much complexity initially. I'm going to talk about how the process works without any complexity, and then we're going to talk about how it works with NAT in a little bit later. All right, so now that we understand all of that, let's talk about how the IPsec policy or the profile comes into play. Now, you can use the same transform set if you want to. What ends up happening with this guy is you have a tunnel. Let's say we create tunnel 1. Tunnel 1 is configured. It's going to have a source and destination information, whether it's like the interface is gig 0/0, the destination is say 21.6.3.8, for example. And then you're going to have, if it's going to be, let's say it's a GRE tunnel, for example. So you're going to have the mode, it's going to be GRE over IP, etc. You're going to tie the profile here with the tunnel protection command. So tunnel protection, then you're going to call the profile and its name. That will turn on, it's a little bit different now. The same process up here works, right? So you got your packet comes into the router, you rip the layer 2 header off, then you do your destination layer 3 lookup, you find it in the routing table, then you move the packet from the ingress interface to the egress interface. But here's the thing, this is where things change a little bit, right? When I do this, my routing table lookup, it's not going to point to gig 0/0. It doesn't point to this. It points to the tunnel 1. Because now I know how the route is reachable out that particular that interface. Because I've either got a static route, some sort of dynamic route, whatever it might be. And then I could take, my routing decision now points me towards the tunnel interface. Now I move my packet from the ingress interface to the tunnel interface, rebuild my layer 2 header because that does not change, and then I will then do the crypto. But how the crypto is done is a little bit different because now I have additional headers. Now I'm doing tunnel mode encryption, not transport mode encryption. The difference is I have the data as before, and then in front of this guy, I'm going to have my layer 4 information. So I have my data in here. And then in front of this guy, I'm going to have my this is the layer 3. This is going to be the source and destination. This is my public IP. Whatever is tied to the gig interface, that's going to be that information. That's going to be the payload before it goes to the tunnel. Once it gets to the tunnel, I need to add some information in here. I need to add a new IP header. The new IP header is going to be the GRE information. That's going to be the GRE tunnel. So the source and destination, or in this case here, it's going to have the source and destination, which will be, the source will be the local part of the tunnel. The destination will be the remote IP of the tunnel, because it's going to be able to figure out who that is. And then I add in ESP. So in here, I add in that information right here. So I have my GRE header, I have my ESP header, and you have that additional IP header added to the mix, which means that you're going to have whatever the additional layer 3 header is, whatever the GRE header is, and whatever the ESP, all that, whatever that encapsulation comes out to be. I forget exactly off the top of my head. I'm going to say 128 bytes to be safe, but it could be smaller or less than that. I honestly don't remember. But you're going to have that additional space that's going to be taking up in the encapsulation part of it. That's actually going to reduce the size of the data that can be sent. So let's say, for example, this piece right here, I'm sending the entire MTU of the packet is 1500. Let's say inside of this guy, I'm only sending 1000 bytes. Well, that 1000 bytes will get chopped down to, say, 800. So there's going to be a couple things that I'm going to need to do. At the tunnel level, I'm going to need to do two things. I'm going to need to throw in there the IPMTU needs to get adjusted to take care of the entire packet. I also need to do the TCP MSS adjustment. So I need to lower the size of my actual data payload that I can send. If you don't do these things, what you'll end up running into is fragmentation, because the packet's still going to be 1500 bytes, but all that additional header space for the GRE header, the additional IP header, and the ESP encapsulation, all that's going to add additional header space that wasn't originally accounted for. So unless you make adjustments at the tunnel level, your 1500 bytes is now, say, 1650, whatever that comes out to be. Then the data has to be chopped up, right? So by lowering your MTU and your just MSS to a lower value, you're actually squeezing less data into it and increasing the amount of size that your header space is going to have, and then send the traffic out to the that's going to fall inside of your 1500 MTU. And that's where that piece is a little tricky to understand the first time you see it, but if you don't adjust anything and things don't work, the pings are wishy-washy, and you start looking into it, it's kind of hard to pick it out. But there's actually some really good documentation. If you were to look up transport versus tunnel mode encryption, you're going to see how that comes into play. ESP is authenticating only the payload. Isn't it better to add AH encapsulation to authenticate entire packet with headers? So ESP plus AH. You can. I've never personally ever ran AH, the authentication payload, or authentication header, because really all it's doing is adding really heavy-duty authentication. But one thing that you can add, and I haven't talked about this yet, is you can add in to the ESP, the transform set, instead of just doing straight encryption, you can also add in integrity. So for those of you that are familiar with the ESP-AES, and you see the ESP-MD5 HMAC, that is what Chris is referring to. This is how you add that capability. So if you're doing just encryption, you're just encrypting the data. So if somebody on the internet has the ability of doing, say, a quantum computer, for example, I'm going to go out and talk about something crazy for a minute. Let's say that they're able to capture your data and pull it down, throw it through quantum grade computing, and then they're able to decrypt everything, right? Then they can see what you're doing. They can change it if they want to, send it on its way to wherever it's got to go, and the user, if they're not doing any type of integrity checking, so ESP MD5 HMAC or ESP SHA HMAC, they're not going to know that the data was modified. So throwing this in right here as a second part of it, if that traffic is captured and modified in flight, they're going to know, because they're going to look at the information on the that's being sent and received, and they're going to know that the signature changed between source and destination. And that's something that I always recommend if you're going to throw in to throw in the MD5 in the checking. You can throw ESP and AH at it if you'd like to do so, but this pretty much does away with AH. AH really isn't necessary in this particular scenario because of the fact that it does that for you. Now, for those of you that are familiar with next generation encryption, now I'm not going to go very deep into this at all because I have not tested it out personally. So if you're looking at doing elliptic curve encryption with digital certificates, what you would, or anything like that, what you'll run into is you'll use, I believe it's ESP GCM, I believe is how you would call it in the transform set. Because again, I haven't actually tested it out myself. I've only watched videos on it, where you would do basically what Chris is referencing. So you have the authentication header and ESP at the same time tied to it. So it gives you a greater level of encryption. It also gives you a greater level of authentication. So it makes it much more difficult to figure out what's going on. So if we set the MSS for any Connect clients who traverse and hairpin through the tunnel, would the packet still be fragmented if we don't see the MSS on the tunnel? That I don't know, because I've never really had to worry about that, and it depends on what's being sent. So if you're so what he's basically describing is you have a AnyConnect user that comes in, or some remote access user that comes in, and then they hairpin out. Maybe you've got your AnyConnect solution set up to where they have internet access after they VPN'd in. Something that I've seen quite a few times. So they hairpin in, and then they go back out to the internet. That I don't know. I'd have to test that out. That is one thing that I plan on testing, because it's something I've never actually ever had to experience. A lot of times what will end up happening is you'll see companies split tunnel the traffic to where only the traffic that needs to be encrypted goes over the tunnel, and anything else just goes out to the internet. Then you remove that completely from the scenario. Not everybody does that, but I'll have to double check on that. Can you explain the difference between transport and when why we use them? So you're talking about transport versus tunnel. You might have just shown up. I already described that. To help you understand it a little bit, kind of recap, when you're dealing with transport mode, you're not adding an additional IP header or any, and you're not adding any GRE or additional IP headers. So really the ESP data is being encrypted right here. So you're just encrypting the data portion of it. So that's basically how that would come into play. And then when you are doing tunnel mode, you're adding in GRE headers, you're adding ESP headers, you're adding additional IP headers. So your control plane encapsulation for your headers, that's taking up more space, giving you less data plane or less data encapsulation. So it makes if you're going to be doing tunnel-based transport, make sure that you adjust the MTU and the MSS down to allow for that additional payload. Am I correct in assuming it's subject to fragmentation because it uses two different interfaces? No, I don't think so, because because I've done that before. I've done hairpinning. So if you're terminating any connect on the outside interface, say gig 0/1, and then you're also setting up your internet-based NAT to do gig 0/0, or whichever interface you're terminating the AnyConnect on is also your NAT enabled interface, and you're setting up the policy to allow hairpinning. No, because the AnyConnect is only encrypting with it's SSL. So if you're doing IKE v2 IPsec, potentially, but I haven't tested that out with hairpinning, so I don't really. So I'd have to be honest with you, I'd have to test it to give you a more specific answer. I have not tested that out with IKE v2 IPsec, but I can't remember a time when I had any users complaining about doing that type of stuff. But if you're talking about bringing in AnyConnect users and then terminating them on your ASA and then allowing them to hairpin out to go back to the internet, I don't see how that's going to add any complexity, to be honest with you, because you're terminating the traffic on the box and you're ripping off the encryption and then just allowing them to go out to the internet. So I can't think of any scenario where that would come into play unless you're doing some sort of like data transfer, like an FTP flow, or you're downloading something that's larger file. And then you got to remember, when you're dealing with AnyConnect, you've got two different tunnels that are being spun up. You got the parent tunnel and you have two child tunnels. You have one that's for TLS, for any type of DTLS, which is going to be real-time traffic. So basically UDP communication, voice, video, that type of stuff. And then you have the other TLS tunnel, which is for anything that's going to be like going to a web page, an internal web page, or opening up an RDP session, things like that. So it depends on which tunnel you're using and how. If you've turned DTLS off, so some people do that. I'm really not sure how that would really affect anything. I haven't really tested it out, but good question. I honestly don't know off the top of my head. I'm at hairpinning via another IPsec tunnel. So you'd have to give me break down the scenario you're referring. So you're coming in via AnyConnect and you're leaving out VTI, going to some other location. Is that what you're referencing? So you come into your HQ location via AnyConnect and you VTI to a branch? Because it's basically what it sounds like you're describing. If transport mode is much lighter, why we even use tunnel mode? Tunnel mode changes the way that the router does this lookup. When you're doing transport mode, you're using a crypto map. When you're doing tunnel mode, you're doing a tunnel. So the routing decisions and how traffic is encrypted changes. So if you have the luxury of using tunnels, use tunnel mode. Make sure you adjust your MSS. I'm not going to. I already went into that. Review the recording, the playback, and go watch that portion of the video. I'll try to do some timestamps and add it in there so you'll see it. So I already went over that in I think pretty deep, but so yeah, good stuff. All right, so now we've covered all of that stuff for phase 1 and phase 2. I'm going to go ahead and any connect user enters via outside interface and out to AWS via VTI. I can't see any reason why fragmentation would be coming into play. I don't have enough information. And why aren't you having your users go to AWS directly? I guess you might have a legit reason for it. The VTI is protected via I get that, but are you experiencing these problems? Is that something that you're asking me to solve your problem for you? I don't know off the top of my head. It's not something I've ever. Very rarely do I ever have somebody come in via AnyConnect and then ride over a VPN somewhere. So it's really difficult to answer your question without diving into it deeper. Do CCNA go deep in the IP? No. CCNA doesn't go into any level of depth as far as I know with IPsec. The CCNA is also an entry-level Cisco cert, so no, they're not going to. CCNA security did a little bit, but if you really want to dive into it, you need to go CCNP security, specifically the new VPN exam. It goes way, way deeper. So yeah, if you want to know more about IPsec, go target the certifications that specifically target that, like the 300-209, which is the old CMOS CCNP security exam, and then the new SVPN, which is what I'm currently studying for. All right. Good stuff. If you have any more questions, send them my way. I'll try to answer them. But if you've got a work-related scenario and you're trying to just, for whatever reason, you're trying to figure out what's going on, I'd have to look at your specific use case. So at a high level, the way that it operates, I don't think you're going to have any fragmentation issues, but I would reduce your VTI tunnel. I'd go to that level and I would throw in your IPMTU reduction and your TCP adjust MSS just to be safe. Lower them down to a lower value so you have more data. So you're taking away from your data encapsulation. So you have less data you're going to send over the tunnel and give yourself more payload for the encryption and the additional header space that you need. And that will hopefully, if you are running into fragmentation issues, that will solve it. That's probably the simplest answer I can give you, because when I've terminated connectivity for users doing Skype for Business over a tunnel to a HQ from a branch office to a DC, and then from the DC they went out to the internet, we had to do just that because they were getting fragmented. There was fragmentation, but adjusting the IPMTU and the TCP adjust MSS commands at the VTI level of the interface, then that should take care of any problems you might be having with that. But I haven't tested it with any Connect, so I don't know if that would add any complexity. But I will try that out. I'll give it a whirl and see what happens, because I happen to have an ASA firewall that I can do that on. So I'm going to go ahead and clear the screen. I'm going to come up here and we're going to start taking a look at the actual implementation pieces. So I'm going to go ahead and start laying this stuff out. So we're going to do a site-to-site VPN out of the gate with the crypto map between CSR1 and CSR8, and then we're going to go through and start adding in some of the other locations. Like CSR10, we'll add a site-to-site VPN, and then we'll do ASA2 and get him up and running, so that R14 and this CA server, which is just a router, we'll do the test connectivity over that to see how it all comes out, get that all squared away. So I need to do a little bit of additional, we add some text in here, and we're going to go and I'll say this will be 10.1.100.0/24. Put that right up there. That'll be this subnet. No worries, man. A lot of people are new. It's all good. But nice thing about it is you have there's a plethora of information on the channel already. So if you have any questions, go check out some of the stuff that I've covered on those things, and I'm sure there's an answer somewhere. Or ask a question on the video. I'll do my best to answer it. So I'm going to go ahead and duplicate that, and we'll bring this guy down to here, but I'm going to go ahead and give this a different subnet. So I'll come in here and do 10.2, whoops, 10.2, and then we'll put in here, we'll put in 148 right here. Duplicate that, and I'll make this 149 on here. So we have a different subnet to play with. 149. All right, cool. So now we have that going for us. I'll go ahead, and I didn't do this earlier, so bear with me so I can get this stuff squared away. I will 10.10.0.0/16, and then I will do go ahead and give this 10.24, and I'll put in here, this will be 10.24.24, and this will be a /24 right here. Oops, /24. All right, cool. And you guys couldn't see that because my big old head was in the way. All right, so what I'm going to go ahead and do is move this guy over here real quick. So if I need to do anything in the interim, we'll be able to get the config going between these guys right here. I'm going to go actually ahead and get out of the way, and I'm going to pull up the CLI and get this bad boy started. So I'm going to start on CSR1 and get him squared away. The first thing that we have to do in the configuration is I'm going to go ahead and configure the internal networking real quick so that R14 can ping CSR1. So do you make your own labs and topologies, or you subscribe? No, I create all of my, I don't subscribe to anything. I create all of my own labs by playing around with the stuff, figuring out how it works, watching videos and learning how it works, testing it out, and then I create my own labs. I don't pay anybody else to do them. Interface gig 2, IP address of 10.1.100.1/24, and then I'll go to R14. Interface gig 0/0, and then 10.1.100.14/24. And then I'll go ahead and do a router EIGRP1, network of 10.1.100.0. And then I'll go back to CSR1 and router EIGRP1, network of 10.1.100.0. Get EIGRP working. So these guys are now adjacent with each other, so now if I learn anything, I'm that much better off. We'll take a look at a couple of examples here in a few on how you can expand this config and things like that. So the first thing I need to do, let me jump out of global config and do a couple show commands. We're going to do a show crypto, and you have the ISAKMP, and you say default policy. Guess what? We have all these default policies that we can play with. So as you can see, we have 65507, 65508. So these are all pre-built ISAKMP policies that are on this router that are available for you to use. So we can see the encryption is AES 128. We can see SHA. We can see RSA. This is going to be a certificate-based ISAKMP policy. The Diffie-Hellman group is 5, and the lifetime is a day. So, and there's no volume limit. So there's no, the tunnel's not going to die once you reach 1 meg of data transfer and stuff like that. Then if you come down here, 6508 is the exact same configuration as 65507, except for we're using a pre-shared key. Obviously, a certificate is going to be typically more secure than a pre-shared key is, but as you can see as you're going along, when you get to 65511, RSA, triple DES, so it's less secure on the encryption piece, and then you go to 65512, pre-shared key there. So it gives you some flexibility. If you don't want to configure that, you don't have to. We're going to co-create our own because, well, that's just how I'm going to do it, because it makes it easier to configure. I can configure off the top of my head, and I'm going to walk you through how that comes into play. So I'm going to go to global config. I'm going to type in crypto ISAKMP. I'm going to give it the policy number, and remember that the policy, the lower the number, the higher the priority. So I'm going to put in here 10 and hit the enter key. Now underneath here, I'm going to specify a couple of details. Authentication in this case here will be a pre-shared key because we're not doing any certificates right now. I'm going to do the encryption is going to be AES, and I can specify how big of a key. Out of the gate, 128 is the default, so I'm going to use 192. I'm going to do, for the group, I'm going to use group 5. And then for the hashing, I'm going to use SHA-256. Now, SHA-256. Now, one of the things that I want to point out, and actually let me move this back over to here. One of the things that I want to point out is when we go to configure a site-to-site VPN between CSR1 and the ASA, some of these attributes won't match. So we'll have to go through and create another ISAKMP policy to affect those configurations. So I've tested this out before. ASA doesn't have super strong ISAKMP policy configuration options, so we'll have to create another policy to match on the ASA. All right, so the next one we have to do is we have to create the pre-shared key. So crypto, ISAKMP, and then we have key. This is going to be our pre-shared key, and then we're going to give it a value of Cisco 123. This is going to be our password, and then the address. We can do an address which will allow us to tie to an IP. So in the address, I can specify who it is that I'm going to be peering to. In this case here, I'm going to go in here and type in 108.0.0.10, which is going to be CSR8's public interface right here. And that's all I have to do. This host name here is if I'm going to be using DNS to go look it up. So if I want to go do a DNS lookup, I can call the name of the device versus the IP address of the device I'm trying to connect to. All right. Now, if I do show IP route, you'll notice that I have no default route in the routing table. And that's a bad thing. I need to create a default route. So do ping, or I'm sorry, IP route, all zeros because it's a default, and then 101.0.0.1. So I now have a default route. Why is that necessary? Well, when R14 sends traffic to CSR1 that is destined to CSR8 or this guy right here or this switch that it's LAN-to-LAN connectivity, if this router doesn't have 10.2.148 or this subnet right here in its routing table somewhere in here, then it's going to fail because the router won't know where to send the traffic, and we'll get destination host unreachable. So this default route is here to say anything that I don't know how to reach, send to this IP address, which is going to be the INET router, and then he'll know how to send it to CSR8 because they'll be directly connected to each other. So that's where that will come into play. All right, so if I do show run section crypto, we're going to see that I have my couple pieces of config in here. I have my policy and I have my pre-shared key. You can ignore any of this stuff right here, which is me playing around with some certificates. So I'm going to go ahead and pull up Notepad, and I'm going to take this information right here, and I'm going to copy it out and put it right here, so I have it for reference later. Next thing I'm going to go ahead and do is I'm going to scoot this guy up, and we're going to look at CSR8. Do show IP route. I don't have a default route either, so IP route, all zeros, to 108.0.0.10, or sorry, .1. Now on the INET router, I don't remember if I configured this guy or not. I did not. So let me go ahead and configure him real quick. And we'll configure some of the basics real quick. Let me come down here. Go to global config, hostname is INET, and the interface gig0/4. IP address will be 101.0.0.1/24. And then we'll go to gig 5. And gig 5 will be 108. And then we'll do gig 000. And that'll be 110. No shit, that guy. And then we'll go to gig 1. We'll make that 103. No shut it. And then we have to do 102 or gig 02, which will be, I think, we got 102. 102.1. No shut that, and then we'll do gig 7. 107 will be, or gig 07 will be 109. And then we'll no shut that guy. All right, so now that I've got all that good to go, I should be able to do give that a couple seconds to do its thing. Do show IP interface brief. Okay, the only thing that isn't configured now is gig 03 and gig 06. And I don't need either one of those guys working right now. We can come back at a later point in time and configure the DNS server that's right here to have this information, so we can switch our config on this guy from an address right here to an actual name. So you'll need DNS resolution for that to work. But let me go ahead and get this guy squared away. Let me go over to CSR8, and we're going to do ping. That'll be 101.0.0.10. And I can ping it. If I do trace to 101.0.0.10 numerically, so no DNS lookup, I should be able to go through the internet provider right here to get to where I've got to go. So the first thing you want to do is validate the underlay is working the way that it needs to be. So we have that going for us. So the next thing for me to do is to take what we configured here, and I just need to adjust some details. So instead of this being 108, I want to make it 101, and I need to just copy all this right here into CSR8. So CSR8 will have the exact same configuration that CSR1 does, because again, this stuff needs to match. All right, so I'm going to go ahead and minimize this guy. I'm going to go back to CSR1 and finish my config. The first thing I like to do is create the access list. What is it that I'm going to match on in order for this to work? So I'm going to type an IP access list. Extended is going to be the VPN ACL, and underneath here I need a permit 10.1.100.0 permit IP. Permit IP 10.1.100.0 0.0.0.255 to a destination. Where am I going? So 10.2.148 to 10.2.148.0 0.0.0.255. Because remember, this is source, this is destination. Let me break it up. This is source, this is destination. Now, what will be cool about this is once I have this in place to do the NAT exemption here in a few minutes, it'll be simply modifying this config a little bit to allow that communication to happen. So that's my VPN ACL. The next thing I need to do is create my transform set. So how am I going to encrypt the data? So crypto, IPsec, and then transform set, I need to give it a name. I'm going to call this the VPN tset 1. And underneath here, I have a bunch of different options. A lot of this stuff you don't really need to worry about too much. Somebody was mentioning earlier about the authentication header, and this is where you would configure that. I'm going to be using ESP, so actual encryption of the data, and I'm going to choose ESP AES. ESP AES is there, and I'm going to go ahead. If I wanted to hit the enter key, I could do that. I'm not going to do that though, because I want to take in and add, if I wanted to add a higher level of encryption, because this is a standard 128 bits, and if I wanted to say do 256, I could do 256 if I wanted to. So I'll throw in 256 for good measure. Now I need to do my authentication. So here is where you can do the HMAC. Yeah, it does for sure on the CCNP, the NRC stuff. Yep, 100%. If I want to do authentication header, so super duper authentication, I could do that, or I could do ESP. I'm going to choose to do SHA HMAC because it gets the job done. That's going to be what I use. Now underneath here, the mode, I either have transport or tunnel. I'm going to be using transport-based encryption because I don't have a tunnel that I'm tying myself to. But if you wanted to do tunnel mode, you could do that as well. I'm going to choose to do transport because that's the default. So there we have that. So now that I have my access list created, and do show crypto IP. Actually, let me jump out of global config. Show crypto IPsec transform set. You can see that I have the default transform set, right, which is ESP SHA HMAC, and it's in the mode of transport. I can actually, I'm going to flip that over to transport here in just a second. And then, because in this case here, this is the default operation for this particular IPsec, or this particular transform set. And then I'll switch, and this one here is tset 1. We're doing 256-bit ESP encryption with SHA authentication. So if I go back underneath that and type in crypto IPsec transform set VPN tset 1, and then set, let me throw this in real quick, and then do a mode of transport, and do that output again, you'll see that they're both transport. So I'm going to go ahead and go to global config again, and now that I have my ACL called and I have my transform set defined, I can go ahead and configure my crypto map. So crypto map, the name of it, I'm going to just call this CMAP, and then I have to give it a sequence number. The sequence number is going to allow me to have multiple peerings configured underneath a single crypto map. So in this case here, I'm going to give it a 10, and I'm going to call this IPsec ISAKMP. If I was doing get VPN, I could call it GDOI for the group setup, but I'm not doing that. If I was doing dynamic crypto maps, if I wanted to optimize my config, I could use a dynamic configuration, but that requires some additional config, or I can call it profile. I'm just going to hit the enter key. And it says the crypto map will remain disabled until peer and valid ACL have been configured. Okay. And you'll notice it says peer and ACL, nothing about a transform set. Because out of the gate, it can call the default IPsec transform set. So we're going to come underneath here and say match the address in the ACL of VPN ACL underscore ACL, and then say set the peer to be 108.0.0.10. And if I do show run section crypto again, we can see everything's good to go. Now if I apply the crypto map to the outside interface, it's going to use the default crypto IPsec transform set. I don't want it to do that. I'm going to say set the transform set to be VPN tset1. And I could add multiple proposals if I wanted to. I don't have to just be limited to just a single one. And there we go. So if I do show run section crypto again, you will see that now I'm calling VPN tset1. So my configuration at this point is complete. Now all I have to do is apply the config to interface gig 1 and type in crypto map cmap. And after a couple seconds, boom, ISAKMP is turned on. So now what I get to go do is I get to take this config right here, and I get to call my transform set and my crypto map. I get to come underneath here and map that there. I'm going to go ahead and put a bang in there just so it's easier to separate it all out. And I also need to come in here and do show run section access dash list. And I'm going to grab this syntax right here and copy it out and put it right here. So let me go ahead and put a bang there. Now, here's the part that gets a little interesting. This is all my configuration. Now, right now, this is CSR1 pointing towards CSR8. This is this flow coming from here going to here. To apply the remainder of this config, so the ACL, the transform set, and the crypto map to CSR8, I need to make a couple of modifications. The first thing that I need to go do is I need to modify the ACL. So I need to move this from here. I need to actually cut it out and put it at the end, because now 10.2.148/24 will be my source and 10.1.100 will be my destination. So I'm going from CSR8 to CSR1. That's the flow changes. And I need to change this to be 101. Okay, so now that I've got that all in play, I should be able to copy and paste my config in like this. So I need to grab all that information right there because the CSR8 already has everything else, and paste it in. All right, so do show run section crypto. Everything looks good. So now I'm going to go to interface gig 1, crypto map, cmap. Okay, now that that's all good to go, let me go down to switch 14. Host name is going to be switch 14. And then interface gig 0/0. I'll say no switch port. Type an IP address of 10.2.148.14/24. And router EIGRP1, network of 10.2.148.0/24. Go to CSR8, do the same thing. Interface gig 2, IP address of 10.2.148.8/24. No shut it. And then router EIGRP1, network of 10.2.148.0, like that. So here momentarily I should have an adjacency, which I do. Now here's the cute part. If I go to router or switch 14 and I do show IP route, I have adjacency, right? But I don't have anything learned from router 8. And if I go to router 14, do a show IP route, right? If I show IP EIGRP neighbors, I have an active adjacency, but I don't have any learned routes. So what I'm going to do here, quickly name this guy R14, save the config, is on the respective device, I need to actually configure CSR1 to say, okay, use me as your default gateway. So underneath interface gig 2 on CSR1, I'm going to type in IP EIGRP, IP summary address for EIGRP1. I'm going to go ahead and just set the default route outbound. So that'll resynchronize the configuration. And now R14, if I do show IP route, I should have a default route in the routing table that points to router 1. and the same thing on CSR8. So on CSR8, I'm going to go to interface gig 2, IP summary address, EIGRP1. This is going to be a default route. It tells switch 14 to point itself to router 8 in order to get to where it's got to go. So a couple little things that you definitely want to pay attention to when you're going through and getting this all set up. So what I'm going to do is on CSR1, I'm going to go ahead and do a debug crypto ISAKMP. And I'm going to go on CSR8, and I'm going to do a debug crypto IPsec. And do that. I'm going to take this guy off screen just a little bit. And on INET1, I'm going to capture on gig 0/4. Alright, so we can see that going on back and forth. I'm going to move this off to the screen just a little bit. And we have that. I'm going to go ahead and pull up Secure CRT again. And I'm going to do a quick test between CSR8 and CSR1. I'm going to ping 101.0.0.10. This is just to prove that you can see the IP or the ICMP communication going back and forth, which means we can communicate back and forth between the devices. So now if I go to switch 14 and I want to ping 10 dot, and what is R14's IP? 10.1.114. So if I ping 10.1.100.14 and I just send it, what happens? Does it actually work? And it does. Alright, so what I can do is I can come in here and do a ISAKMP or ESP. Let me bring this down just a little bit. And you can see that we had a lot of data going back and forth. Let's take a look at CSR1. I'm going to do an undebug all. And we're going to look at phase 1 first real quick. I'm not going to do a deep dive on it. I'm just going to take a quick look at it. And there's a lot to unpack here. So let's just start off. We can see received a packet from CSR8, destination port 500, meaning that it's using ISAKMP without any NAT. If you're going to deploy NAT, it's going to be UDP 4500. Created a peer structure to this guy on peer port 500. And then we inserted an essay in the table. We come down here, we're checking ISAKMP transform 1 against priority 10 policy. All these values matched. Okay, says the attributes are acceptable. And then it goes through some other options. It does a NAT-T or NAT traversal thing, looking for is NAT traversal being used? Is there dead peer detection being used? Things like that. It doesn't detect anything. So we start going to main mode message 1 and main mode message 2. And I'm not going to go into a ton of detail on that right now, but it's basically going through its main mode operations. There's 6 total messages sent back and forth. And his has no match, this node outside NAT. We're not actually doing NAT, so no NAT found for self or peer. So it doesn't detect any NAT. It does detect it's an iOS box, however, which is kind of cool. We go back and forth. There's some information that's sent back and forth. I don't remember off the top of my head what main mode message does what. I'd have to go look that up because it's not something I've ever memorized. But if we look through here, we can see that we're going through and verifying all the details. And we can see that the ISAKMP policy seems to be working out. And then if we come down here just a little bit further, it says IKE phase 1 complete. And that's when we would so now we're going to go to, it says phase 2 complete as well. But if we go to CSR8, this is where the IPsec piece comes into play. Let me scoot it up to the top here. We can see that we have a connection coming inbound. This is local is CSR8, remote is CSR1. The local proxy. The local proxy means that this is the proxy ACL. If you ever heard that term, you know what it means. We're saying that 10.2.148/24 and 10.1.100/24 will be encrypted. And it says the protocol is ESP, the transform is ESP with 256 bits of encryption. It negotiated the mode of tunnel even though we configure transport. We go through here, we can see the proxy matches comes up, the protocol is 256 bits. Everything's looking pretty good, and that's pretty much it. If we do a show crypto ISASA, we have an active tunnel. If I look at the detail, I can see that we're going back and forth, and we can see that the status is active. The encryption is AES SHA-256 pre-shared key Diffie-Hellman group 5. It'll be up for about a day. If I look at the show crypto IPsec SA, come down here, we look up here a little bit, we can see this is our entry. We have our local and remote identities, so what traffic is actually being encrypted. We can see that when it came to packets encrypted, which is traffic being sent, and then the information being encrypted, and then traffic being decrypted. So traffic that we received from the remote endpoint and decrypting it to allow it to come through. Now, one thing that's interesting about this is when you talk about how IPsec works, when it comes to the phase 1 part of it, or this piece right here, this is a bidirectional communication. So there's one phase 1 communication that goes back and forth. They verify that information. When we talk about IPsec, the actual data encryption, the data plane, there's actually 2 tunnels, one going out and one coming in. So if we were to look at this here on this guy, you'll notice that we have a inbound ESP SA right here, and we have an outbound ESP SA. If we were doing authentication header, you would see an inbound AH SA here, and an outbound AH authentication header there. But since we're not doing any type of authentication header, those aren't there. I don't know what PCP is. I can't say that I've ever seen that one before. If you know what it is, comment below, but I don't know what PCP is off the top of my head. I know what ESP is, so we can see that that's going back and forth and the details to that. Now the question is, if I wanted to go from switch 14, I wanted to telnet to R14, I'm going to go ahead and get that set up real quick. So line BTY 0 / 4. Type in login local, and transport input is all. Type in username is going to be Rob, privilege level 15 with a secret of Cisco. And then I'm going to go to switch 14, and I'm going to ping that traffic again. The ping goes across without a problem. Or ICMP. Yeah, you won't see ICMP because it's no longer being sent across the wire. So what I'm going to do now is I'm going to do a telnet to 10.1.100.14. Type in Rob and Cisco, and you can see all the communication going back and forth. I don't know if you're seeing all that, but you see a lot of data. If I go to CSR8 and I hit the up arrow a little bit, you see a lot more data going back and forth, right? Now, if I was to come in, let me do an undebug all to get rid of some of this additional output. If I was to do a show crypto IPsec SA pipe include PKTS and peer, you would see this going back and forth. So let me go ahead and on switch 14 do a show IP interface brief. Oops. All right, so anything that goes across is going to trigger more data. So if I hit the up arrow, we're going to see that a number of additional packets were sent back and forth. Okay, so these are some of the things that, with the basic site-to-site VPN, that you're going to need to know about. Okay, so now that we have that set up, now we need to take this a step further. Let's take it to the next level where we dive into adding in another location. We add another location in, and we need to configure CSR1 with an additional entry in the crypto map and things like that. So I'm going to go ahead and minimize this. And what we're going to do is I'm going to go ahead and set up the site-to-site VPN between ASA2 and CSR1. So I'm going to pull this guy back up, and I'm going to go through and make some adjustments, because what we need to do is we need to account for the additional information that's happening at this location. 102424 needs to be added in to the ACL. We need to make sure that there's a crypto map entry 20 here, and we're going to have to adjust our ISAKMP policy on CSR1. So I'm going to go ahead and configure the ASA first, and then we're going to see how that comes into play. So in ASA2, I already have it initially set up with some basic IP addressing, show route. So I need to create route internet, which will be 0.0.0.0 to, and this will be 102.0.0.1. So if I do ping 101.0.0.10, that should work, and it does. So now I have reachability to that guy. So now I have to go and configure the VPN on the ASA. A lot of the same configuration applies. So I'm going to come in here and type in the crypto, and it's going to be the IKE and it's the policy, and I'm going to give it a number of 10. I'll set up the authentication. The authentication will be a pre-shared key. The encryption will be AES, and I'll be able to do 192, so that'll match, -192. I will say that the hash will be a SHA, and this one here doesn't support SHA-256. So I'll have to make sure that when I configure the new policy for the ASA that the SHA option will be just SHA-1. And then the group, I'll be able to say 5. So we're good to go there. The next thing for me to go do is show run crypto. And there's my policy. So I'm going to go ahead and pull out another notepad doc. I'm going to copy this guy out. I only have one ASA in here, so it's not that big of a deal. But I want to make sure that when I'm configuring my stuff that I make the adjustments necessary. I don't want to commingle everything into one file. Now I'm going to go ahead and configure the pre-shared key. But the way that the ASA does it is different. You don't type in crypto and then IKE and then configure your setup here. You actually have to create what they call as a tunnel group. So we're going to type in tunnel group, and the entry that you put in here isn't the name of who you're trying to peer to. It's the actual IP, unless you have DNS set up. I'm going to type in 101.0.0.10, and then it's going to be type of IPsec L to L. Now I've got that, and now I need to come underneath here, and I need to come in here and add one more option here, and I'm going to say the general attributes, hit the enter key, and now I get to specify my configuration. So, or is it, sorry, no, so it's IPsec attributes, sorry, not that one. I didn't say IPsec attributes. Underneath here we go, sorry, wrong one. Then we have, underneath the IPsec attributes, we have to create the IKE, and it's going to be a pre-shared key, and we're going to just type in here Cisco123, and that's it. There's nothing more for us to do. If we were doing IKE with, we would have to set a local and remote, but we don't have to do any of that here. We just have to do the basic config, and we're in really, really good shape. So we do a show run crypto. We have our, the crypto won't show underneath here. We'll have to do a show run tunnel group. We can see our tunnel group is configured. So we'll just grab this guy out here. And it doesn't show us what the config is. That's not that big of a deal. But what I can do, if you want to know more about that, you type in more system running config, and you do a pipe to begin tunnel group. You'll get the config right here. Tunnel group is right here. So if you want to know what the actual value is, just copy this guy right here and replace the stars with that. That's how you would do that. Now the next piece for me to go do is to configure the IPsec transform set. So, or actually, let's do the ACL first. So crypto, or the access list, and we're going to give it a name. It's going to be VPN underscore ACL, and then we're going to say the extended, and we're going to say permit IP, and say 10.24.24.0/24. There is no wildcard configuration in this variation. And we're gonna, so the destination we want to talk to is going to be 10.1.100.0/24, and do that. And that's going to be our VPN config, or the VPN ACL. So I'm going to go ahead and show run access dash list. That's our configuration for this guy. And then I'm going to go ahead and create our transform set. So crypto IPsec, and it's going to be IKE transform set. I'm going to call this VPN tset1, and then we are going to set it to be ESP. What did I configure this one? Whoops. This one is ESP AES. Oh, we'll do 256. Okay, it must be a newer version of code. I must be working. The gear that I'm working on, sometimes it's older and it doesn't have the newer options. And we can do ESP SHA HMAC. So the transform set is good to go. So we have that. So our transform set will match here. The only thing that's going to get changed a little bit is the policy. All right, so now we have that. I don't know if we can set the mode. I'm not aware of that being able to be done. Crypto, IPsec, IKE transform set, VPN, tset1, mode. Oh yeah, you can't set a mode, transport. In this case here, it wouldn't matter because, well actually it would, because this ASA does support VTI. We're not going to be testing it out today, but it does support VTI. We were to do interface tunnel, we could configure that, and then underneath here you would set the tunnel mode would be IPsec IPv4, so it does support that. It's only only SVTI though. So we have that. So show run crypto, and that's up here. So we're going to go ahead and grab these two lines of config and drop that in like so. And then the next thing for me to do is create the crypto map. So I'm going to get out of here and type in no interface tunnel 1. And we're typing crypto and then map. And we're going to say CMAP. And this one gets a little interesting. You have to give it the sequence number. We're going to say 10. And then we're going to say set the peer to be 101.0.0.10. Unlike iOS, where you would go underneath the crypto map config and then you just hit the up arrow and make modifications, this is a one-liner. So we'll have to make some adjustments as we're going along. So in other words, come in here, set the transform set. It's to set the IKE transform set, and it's going to be the VPN tset1, and then we have to match the address in the access list, which is going to be the VPN ACL. All right, now that we've done that, let's do a show run crypto one more time and pull that config out, which is up here at the top. We have our crypto map config. And then we'll dump that right here. Then we have to go and enable crypto on the egress interface. So we'll type in crypto, and then we have to say on IKE and then we have to enable on the internet interface. That's the first thing we have to do. And then we also have to do a crypto map, and then it's going to be CMAP, and we have to say interface internet. So not only do we have to enable crypto for the egress interface, we also have to associate the crypto map to the egress interface. So do show run crypto. A lot of little things to remember how to do when it comes to setting this stuff up. So we have that guy right there, and then we have this guy right here. Crypto map. There we go. All right, so that's everything that we need to have in place for this to work. Now that we have that, now I have to go and adjust this policy, now I have to go configure the CSR1 again in order for this to work. So CSR1, very similar config, except for I'm going to go ahead and modify some of these values. So instead of it being, let me go ahead and take this guy here and move it back over here to the beginning. Instead of it being 10 to 148, it's going to be 10 to 24, 24, and that'll be what we need to do. But I'm also going to need to put in here permit, I'll put in 20 here, so it's the next sequence number. And then I need to specify who I'm pointing towards. So in this case here, it's going to be 102. And if we remember our config from our phase 1 policy, the hash of SHA, I'm going to put in here 20. And then I need to take the SHA 256 and make it just SHA 1. Everything else looks like it's going to work the way that we need it to, which is really, really good. So everything else, I believe, if we compare apples to oranges, I think we're in good shape up to this point. And then I need to go into here, and on the crypto map, I need to adjust and add a sequence number in the crypto map on the iOS router, add in a second sequence number, and the T set's going to match, so the transform set is good. I don't need to mess with that. But what I do need to do is set the peer to be 102.0010, and that's going to be the only other piece of the pie that needs to be squared away. So I'm going to go ahead and I'm just double checking my config. Policy 20. Policies don't need to match on either side. It just needs to be similar attributes, or the same attributes on both sides. So I think we're good. I can't see anything that would potentially screw me up. Let's go ahead and copy this information into CSR1. Go ahead and jump into CSR1, go to global config, and a copy and paste. If I've done my job correctly, we do a show run section crypto. Over second policy. Okay, everything looks good. So I'm going to do a debug crypto ISAKMP and IPsec again. And on here, go ahead and minimize these guys out of the way real quick. And then on ASA on R4, go to global config, interface gig 0/0, IP address of 10.24.24.4/24, no shut. And then I'm going to configure an IP route to 10.24.24.2. All right, so now I've got that. Let me just double check the ASA config. Interface gig 0/1, IP address of 10.24.24.2/24, no shut, and name if is inside. All right, so now I'm going to do a show route. All right, so show access list real quick as well to make sure that that all is being referenced properly. Okay, so now let me go to R4 and try to ping 10.1.100.14 and do a repeat of, let's say, 10. All right, so hit the enter key and fingers crossed, ladies and gentlemen. Okay, so part of this, I neglected to do one thing. On the ASA, I needed to inspect ping. So show run policy map. I need to go ahead and inspect ping. Try that one more time. And okay, so what are the other, no, I think everything's good. Let me, CSR1, QM rejected. So I'm gonna take a quick break. I have to go use the restroom real quick, so I'm gonna mute myself. I'm gonna take a quick break, and I'll be back in here in just a couple of minutes. I think it's a good time for us to take a pause anyway. We're at the 2-hour mark, and I will troubleshoot this problem when I get back. So I'll be back in just a moment. All right. Thanks everybody for the hanging out and stuff like that. So we're going to go ahead and figure out why the peering did not come up. So I didn't have a chance to really dig into it yet. So let's see. So do I have a show crypto ISASA? I don't. So let's do a show run. I think I know what the problem is though. Show run section crypto. What didn't I configure on this side that needs to be there? Oh no, I got the phase 1 is there. So let's see. I failed phase 1. Or no, phase 1 is good. So it's phase 1. QM idle is dead. Let's try that one more time from 4. We'll do another ping test. Let me just make sure that, do that ping again. CSR1's trying to bring it up. Proposal not shown. So, okay, phase 2 SA policy not acceptable. Let's just do a quick check real quick. Okay, so phase 1 is configured correctly. Phase 2 is the problem. All right, so what I can do is here on phase, this guy right here, do a show run crypto and look at the phase 2 piece of it. What is ESP AS256? Let's do a show access list. 1024, 1024. 1024, 24. Make sure this side is show IP access list. Okay, that's all correct. Show crypto IPsec SA. Okay, it's trying to do it. Let's do pipe include PKTS and peer. Oh, wait a minute. Did I make a mistake on that? One second. I think I'm... Let's do an undebug all. Show run section crypto. Let me just double check my config here. Crypto map is... VPN ACL. Oh, I see. Okay. So in this case here, okay, so here's the problem. So it's and so the last person that commented, you look like you're chatting to me in, I believe, Cyrillic or whatever, and I believe you to be Russian potentially. I could be wrong, but I don't understand. I don't understand Cyrillic. You'll have to excuse me. So the problem is that I'm calling the same ACL. Okay, and so here's the problem, and this is oversight on my part. The problem is that CSR1 and ASA2 don't have the same subnet sitting behind them, or the configuration. So when you look at the show IP access list here, they're not the same. So this is going to be connectivity for traffic between CSR1 and CSR8. This will be traffic from CSR1 to ASA2. So I need to separate them. So I'm going to go ahead and quickly adjust the config. So I'll type an IP access list, extended VPN ACL CSR1 CSR8, and I'll type in permit IP 10.1.100.0, 0.0.0.255 to 10.2.148.0, 0.0.0.255. Whoops. And then I'm going to come out here and do an IP access list extended VPN ACL CSR1 to ASA2 and permit IP 10.1.100.0/24 to 10.24.24.00.0.0.255. That's really what the problem is. So what we're going to go do is do show run section crypto and change that up. So we're going to go underneath the crypto map. So I'll come underneath here and I will swap, say, this guy here will actually be this value right here. And then crypto map, this guy will be this value right here. So do show run section crypto. There we go. So the problem was, just so we recap it again, is I was calling the wrong ACL. But the ACL was, when you do that, remember both sides have to match on both sides. So whatever ACL you have configured on one side, the opposite has to be configured on the other side. So if I go and try this one more time, and try R4 one more time, this should work now. Hopefully. Assuming that I've done everything correctly. Let's do a show access list, or show crypto ISA SA. That's MM active, and show crypto IPsec SA. He is still not liking whatever I'm doing. So this side here, let me just double check the ASA side. Show run crypto. I'm sorry, no. Yeah. Crypto map. VPN ACL. So show access list. Okay, so it is definitely sending it. But why is it not terminating? Show crypto IPsec SA pipe include PKTS peers. I also need to do ident. Okay, so we got further along. Now what's happening, let me go ahead and scoot this up just a little bit so it's easier to see. I wonder, show run section crypto here. I wonder if it's a transform set as well. I wonder if that's messing us up. Let me go over here on this side and let's do a debug crypto IPsec. Let's do a 255. Let's do a 1 and try this one more time and see if there's and say logging on, logging, enable, and then logging console 7. Normally I don't like doing that because that can very easily overrun the buffer, but I'm going to do the debug anyway. So on router 4, let's do this one more time. Let's see why this is not coming up. Let me go ahead and get out of the way as well. Show, whoops. Show crypto IPsec SA. All right, so there's no match. So we have show crypto ISASA. Yeah, see, it's kind of in a weird situation here. And no, I did not. Tunnel manager undebug all. So send message 1. So we're you know what I need to do is no logging on and no logging enable. Yeah, there we go. Part of my problem. So what I'm trying to determine here is why. Because when we look here, it says that removing peer from correlator table failed, no match. Kind of a weird situation. So we do a show crypto ISASA. I have my connection from CSR1 to CSR8 up. But when I do it from CSR1, or this guy here, and I do this guy spins up no problem. If we do a show this guy, we get the communication to begin. Oh, you know what, I wonder. Show run section. Let's do a show IP access list. Let me go ahead and say no IP access list extended. Let me just remove this guy and see if that makes a difference. Oh, you know what? Let's go IP access list extended this guy real quick and say no 10 because I accidentally goofed up the config on that guy. Show IP access list. Okay, so that looks a lot better. Show crypto ISA SA. No state deleted. Show crypt. Let's try that one more time. Trying to isolate what the problem might be. And then okay, that's cleaner. So if I go back to switch 14 and I try to ping 10.1.100.14, that should go across. That does. CSR1, we have traffic going across. Let me see why the communication from ASA2 isn't working. Show run crypto VPN ACL tset1. Let me debug crypto IKE and ISAKMP or IPsec and see if that'll help. Try this one more time. Oh, and I have the logging console 6, logging buffered is 7, logging buffered 7, log buffered, and then logging buffer is, let's put in here logging buffer size. That's what I was looking for. Let's put in here just something really, really high. No match. IKE v1. Show log. This has worked before. What am I missing? Show run crypto. Let me remove the transport mode thing. See if this will help us figure this out real quick. And show route. I have a route to the internet. Ping 101.0.0.10. It's definitely not a reachability issue. It's definitely a phase issue. I'm just trying to figure out where in the problem, where it's coming into play. So, oh, there it goes. That was the problem. It was a transport. Okay. So as soon as I did that, as soon as I removed those configs, the VPN came right up. So show crypto ISASA, show crypto IPsec SA. Yep, there we go. So remove the mode, remove the transport mode. That's weird. And it came right up. Okay, so show run section crypto. That's very, very weird. It's weird that that was holding me back. I don't think I've ever seen that before. But then again, you never know until you try, right? All right, so we have that going for us. Now, if we were to try on CSR1 and do a show crypto IPsec SA, we're only going to get one, for every entry in the ACL that we have configured, we're going to get one output here, right? So not that big of a deal, right? But still, it can be troublesome. So what you can do here, and is I'm going to add a little bit of complexity here. I'm going to go configure switch 14. I'm going to configure a subnet between these guys. I'm going to say that this guy will be, I'll duplicate this guy, give this a subnet of, say, 10 to 100. Because that'll be something different. Well, actually, let's do 101. We'll do that there, and then we'll duplicate this guy and do 102. And what I'll have to do is on CSR8 and CSR2, I'm going to add, I'll have to add the subnet on both sides so that the communication can work. So this will add a little bit of complexity to our design. So on CSR8, show IP access list. We'll go in here and IP access list extended VPN underscore ACL. We'll type in permit permit IP of 10.2.101.0 0.0.0.255 to 10.1.100.0 0.0.0.255, as well as 10 to 102. Okay, and the same thing on CSR1. We do show IP access list. We're going to go here, and then the IP access list extended, and then this ACL right here. We're going to type in permit IP of 10.1.100.0 0.0.0.255 to 10.2.101.0/24, and then 102 as well. So that will mean that when I go to switch 14 and I go to global config and interface gig 0/2, no switch port, and I configure this an IP address of 10.2.101.14/24, and I go to router EIGRP1, type in network of 10.2.101.0/24, as well as 102, and I go to interface gig 0/3, IP, and no switch port there, IP address of 10.2.102.14/24, and do show IP EIGRP neighbor. Go to CSR8, do show IP route. I should see 101 and 102 coming in. That's good. And then on CSR, or on switch 14, do show IP route. I still have the default. And then on RSA CA, do show IP interface brief. I don't know if I can figure it out with an IP address yet. Interface gig 0/0, IP address of 10.2.101.100/24. No shut it. And I'm going to say no IP routing. So do show IP route. There's no default gateway, so I'll type an IP default gateway of 10.2.101.14, and host name will be RSA-CA. Do save. And the same thing with the elliptic curve CA. Interface gig 0/0, IP address of 10.2.102.100/24. No shut it. No IP routing. And then I'll say the IP default gateway is 10.2.102.14. Save the config. So now what I'll end up doing is, now that the ACLs have been configured and all that good stuff, when I go to ping from here to 10.1.100.14, it should ping across. And it does. So we go over here to CSR1 and I do a show crypto IPsec SA. We're going to have additional entries. So here's 102, 100, 101, all that good stuff. So let me hit the up arrow a couple times and look at it this way. So what we're going to get is we see from 102, 100, 10.2.101 and 10.1.100, we can see 4 packets have come across. If I go to ECCSA and ping 10.1.100.14, that should also go across, which it does. If I go back over here to this guy, hit the up arrow, and do another one, we can see that we're getting entries for all of them. So here is 10.1.100 to 10.2.102, 10.1.100 to 10.2.101. All that's working. So basically what we're trying to validate is that by adding ACL entries, you actually add more SAs per connection type. So in this case here, it's a site-to-site VPN with using a crypto map, and that communication going back and forth. So we're good to go there. So that just validates that that's working the way that it needs to be. If I go to switch 14 and I do a ping to 10.1.100.14, that should also go out, which it does. Hit the up arrow. So we should have entries on all of them, which we do. So that means the connectivity is working the way that we need it to. Good stuff there. All right, so now we've gotten that done. Let's add a little bit more complexity. Let's take and say that CSR8, we need to have internet access. So we need to be able to go to the internet router, and I want to be able to telnet in from the RSA CA. So this guy right here needs to be able to telnet into the internet router for whatever reason, or open up the web page. So I'm going to come up here and type in IP HTTP, or we'll do line VTY 0/4, login local, transport input is all, and we're going to type in username is going to be Cisco, secret is Cisco, or actually let's say privilege level is 15, secret is Cisco. And then what we're going to go do is on CSR8, we'll notice that show IP NAT translations, NAT's not turned on yet, right? So we need to go to global config. I'm going to create an access list, IP access list extended. We're going to start off with an extended ACL because if we use a standard ACL, we won't be able to get specific with our NAT overrides. So if we want to bypass NAT, say don't encrypt this traffic if it needs to go over the VPN, then we need to have some sort of way of doing that. And then extended ACL is what allows us to do that. So I'm going to call this the NAT ACL, and I'm going to type in permit, basically permit IP of 10.2.0.0, 0.0.255.255 to any destination. We'll be able to go out we'll be able to use NAT. So the next thing I'll do is interface gig 1 will be IP NAT outside, and then interface gig 2 will be IP NAT inside. I'm going to also type an IP NAT inside source list is going to be using the NAT ACL to the interface of gig 1 and overloading. Okay, so we're going to test this out now. We're going to go to RSACA, and I'm going to ping 108.0.0.1. And I can ping it. If I go look over here on this guy and I do a show IP NAT translations, I have a NAT translation working. If I do a show IP access list, I should have an ACL. This ACL entry is not going to show anything because it's not how it works. So I'm going to go over here to RSACA and type in telnet to 108.0.0.1 Cisco. Now I can telnet in. Now here's the tricky thing. If I need to go from RSACA and I need to do a ping to 10.1.100.14, I get this. My VPN is no longer working. How do I fix this? Well, remember what we talked about earlier. I'm trying to jump over the VPN to the remote end. So I am trying to go from here through the switch to this router. Jump over the VPN to CSR1 and then terminate on R14. It's not working. The reason why it's not working is because when I hit this guy right here, I match this ACL because my source is 10.2 something /24. I'm not going to match the proxy ACL inside of the crypto map. Why? Because I'm hitting the NAT entry, I'm matching on this guy. So remember, on the outside interface, the order of operations is once the traffic reaches the egress interface, the first thing that's checked is the NAT ACL. And this matches. This is a match. Anything 10.2 anything is going to match this. So 10.2.101 is going to match 10.2/16. It matches, therefore it's going to get natted. But my destination is not something on the internet. It's something over here. So I need to tell the NAT ACL to not check the traffic for this particular scenario for NAT. So bypass it. So say deny it from being natted and allowed to go over the VPN. Because I do want to go from 10.2.101 to 10.1.100. I do want to use this guy. So to do this, to fix this, I need to come up here to IP access list extended NAT ACL. Let me go ahead and get out of the way, by the way. And type in an entry below 10. So for example, 1, and say deny IP of 10.2.101.0 0.0.0.0.255 to the destination of 10.1.100.0/24. I'm also going to do this for the 102 network. So 102 and add in the entry of 2. So do show IP access list, and now we're going to see these other entries. Now if I go back to RSACA and I hit the up arrow and I try to ping, the ping goes across, right? If I try to telnet, I also can telnet Cisco and Cisco, because now I have entries on here that are matching. It's saying deny these two subnets from being natted and allow them to jump over the VPN. So if I do show crypto ISASA, I have the VPN set up. If I do an IPsec SA, I'm sending the traffic over the wire to where it's got to go. Specifically with this subnet, it does work. So that's basically how that would come into play. So you need to deny the NAT process, but permit in the crypto, because NAT happens first at the interface. If you deny the NAT, then it'll bypass the NAT process and then jump over to the crypto process and allow the traffic to get encrypted. Cool. All right. Now that we have that taken care of, I'm 2.5 hours in. So I am debating whether or not I shouldn't break this up into another session, because 2.5 hours, I kind of need a break. So I know I just took a break a little bit ago, but what I think we should do is I wanted to move through this, but I got a lot of questions and that slowed my process down. So I think what I'm going to do now is I'm going to break this up into a different session, and we're going to take a look at how we can take a look at it from a different perspective So we took a look at a lot of stuff in this session, but we definitely need to look at this in more detail when it comes to doing doing like DMVPN and so on and so forth. But I'm going to break it up a little bit more so that it's a little bit more palatable. We're not doing a 5-hour session because that's pretty much what this would end up needing to be. So that's what I'm going to do. I'm going to break it up. We're going to do another session next weekend. We'll dive more into the VPN piece of it. Take a look at the tunnel base to do the SVTI and all that good stuff that goes along with it. How well does QoS work within IPsec? It actually works pretty well. You just need to create a policy that you can attach a... How does that work now? You'd have to attach to do per tunnel QoS. It's a little bit tricky. I've actually covered that before on the channel. It just needs to be gone over. But that's really it. It's actually not too terrible to get to work. It's called per tunnel QoS. I haven't tried it with crypto, or the crypto map, I should say. So I honestly would have to test it to see how that would play out. But you would just associate it to the outside interface. To whatever interface you're also doing the crypto on, QoS would also just be the matching and the marking and stuff like that would come into play. It usually works pretty well. I've never had a problem with it. You're just trying to prioritize the traffic. But I normally don't do that unless I can guarantee the traffic over the transport that it's going to be using. In other words, I've never really deployed QoS on an internet-facing interface for the simple fact that internet routers don't honor it. So I would have to associate that to MPLS, where I know there's some sort of QoS policy or an SLA that I'm paying for. So you can try it, but I believe the QoS markings are encrypted, so it really wouldn't make much of a difference technically. But I haven't tested it out, so I can't give you a super specific answer. But I've never had a problem with it, is another way of putting it. So you'd have to test it out and see how it works. Honestly, not sure. So anyway, thanks guys for hanging out with me in this session. It was awesome to get back into it, and I'm planning on doing a live session every weekend on different topics. And as the year progresses, obviously the topics will change and things like that. So I'm actually studying for the VPN exam, so this was good for me to test things out. And it's always interesting to have to troubleshoot live on a call. So, but anyway, thanks guys for hanging out with me in today. I will see all of you next Sunday. We're going to pick up where we left off. I'm going to do a little bit of DMVPN with crypto. I'm probably going to spend a little bit of time on DMVPN, but we've already covered it. I really want to dive into the FlexVPN side of the house, do VTI tunnels and things like that, and also do remote access VPN on ASA. So, but I'll cover that later on in an upcoming session. Thanks for hanging out with me today, guys. It was awesome. I really enjoyed hanging out with you guys and getting back after it. And we're going to continue to do these live streams because I think they're beneficial for me as well as being beneficial for you as well. So, you guys have a safe week. Enjoy your week. If there's anything you would like me to dive into, let me know, and I will do my best to try to accommodate as we're going along. So, absolutely, thanks guys for hanging out and all that good stuff. So, take her easy. I'm going to go ahead and kill the stream. I'm going to keep the chat open for a few minutes, and then I'll go ahead and kill that. And I'm going to go take me a break. So, have a nice weekend, guys. Will it be the same topology? Yeah, I'm not going to change the topology. This topology, I'm going to actually create another topology that looks just like it and upload it to, if you become a member of the channel, you'll be able to download this from the file share that I give to everyone when they become a member. So you'll be able to gain access to it. So I'll go create that real quick. It'll take me a little bit of time to do that, but I'll share the topology with you guys. So, all right, ladies and gentlemen, see you guys next week. Same bat time, same back channel. Stay safe out there, everyone. Later.